So in the first video, we found the root of the equation 8x cubed plus 11x squared plus x minus 1 equals 0 in the interval 0, 1. And we're now going to find the root that is in the interval -1, 0. And we can see, going back to the graph that we had before, in the top graph, it is where the graph cuts the x-axis, and that equates to where the graphs y equals x and y equals the root of 1 minus x minus 8x cubed all over 11 intercepts. And what I'm going to do is I'm going to zoom in again like we did before on this section here of the bottom graph, so that we can have a look in a little bit more detail at what is happening. So here's this section of the graph, and we're going to use the same iterative formula that we used before. We've got the two graphs. The red line is the line y equals x, and the blue curve is y equals root 1 minus x minus 8x cubed all over 11. We're going to use the same process as we used before, and we're going to look at it using the spreadsheet and the graph at the same time. So x0 is going to be -1. We know that x0 equals 0 is going to find the root in the interval 0, 1, because we've just done that in the first video. So x0 equals -1. We're going to generate x1 by substituting that into our iterative formula, as I've shown at the bottom, and that's going to generate our value of x1, which the spreadsheet gives as -0.953462589. And remember, this is just to 9 decimal places, because that's what Excel does. And we're going to look graphically. So again, let's follow the same process. We're going to start with our value of x0, which is here at -1. And we're going to draw a line from there to our blue line, our blue curve. And what we're going to do there is we are then looking at this point here, and this is the point x0y. Our y value is, we know, this value here that we've got in our table, because that's the value that was generated by putting x0 of -1, a value of -1, into the 1 minus x minus 8x cubed all over 11 square rooted, because that's the curve, that the blue curve, that's the equation of that curve. We want this y value to become our new x value. So this y value here is going to be x1. And we need to transfer it to a x value from a y value, and we're going to do that by moving horizontally across to our y equals x line. So a reminder of why we wanted to do that is because we now want this point here, which is going to have the same y coordinate, which we want to have as x1. Because we've moved across to the line y equals x, we can say that we also have the same x coordinate. And so our x value is now x1. We can see that if we were to draw, if I just draw a quick line going up to the x-axis, you can see that it's roughly halfway between -1 and -0.9, and so that confirms the value of x1 that we had here in our calculations and that we had in the spreadsheet. So then the next thing that we do is to move our x1 value, we substitute that into our root 1 minus x minus 8x cubed over 11 square rooted. And so we move back up to the blue curve, and that then finds this point here, and that point there is x1, y. And again, we want this y term to be our new x. And in order for that to be the case, we have to move horizontally across and do the y equals x line. And because it is y equals x, it then allows us to have the same x and y value. And so this now becomes x2 is still our y coordinate because we've moved horizontally. And if we move horizontally, the y coordinate does not move. And because we've moved to the line y equals x, our x coordinate is also going to be x2. So you can see that what's happening here, we don't have a cobweb diagram, we have what we call a staircase diagram. And we're going up in progressive steps that are getting smaller and smaller and smaller, and we're getting closer and closer and closer to our root. And we're not oscillating around the root, we're coming to the root from the left-hand side. So our negative values are getting greater and greater and greater, and we're heading somewhere between negative 0.5 and negative 0.4. The values that we have in our Excel spreadsheet, all these values of x are being generated by the iterative formula, and they are being represented by the different steps as you carry up the staircase. So it's clear that our spreadsheet isn't getting near our root. We have only on our spreadsheet gone up to x6, which is the point here, which is the point x6, x6. And so our spreadsheet needs to keep going. So here's the elongated version of the spreadsheet. I'd like you to pause the video and find the root to 5 significant figures. So hopefully you've recognised that when you get to this point here, when you get to your 30th and 31st iterations, that's the first time that you have got to the same point, same degree of accuracy. But it is always worth, as I've said before, carrying this spreadsheet on just to check that it doesn't creep up and creep up and creep up a little bit and a little bit and suddenly tip you into a different value of x. So using 31 iterations, so after 31 iterations, we have got a value that x equals negative 0.43798. And that's to 5 significant figures. Again, I'd like you to pause this video and I'd like you to use error bounds to verify this root. So the error bound is plus or minus 0.000005, and I have substituted the 2 error bounds into f of x and shown, and remember that f of x is our original equation, not it's the original expression in the equation of 8x cubed plus 11x squared plus x minus 1, not the rearranged expression. And so we can see that there is a change of sign in f of x, which confirms that the root is negative 0.43798 to 5 significant figures. So let's now consider what is happening in the interval -2, -1. We're going to use the same iterative formula, and we're going to have the x0 is -2. And you can see from the spreadsheet that the values of x are just going larger and larger in a negative direction. So let's consider what is happening graphically. So if we start with our x0 value, which is on the x-axis here at -2, so that's x0, and following the same sorry, that looks like a 6, it's x0. And following the same graphical method, we're going to draw a vertical line down to our blue curve, remembering that the blue curve is the same blue curve as before, y equals the square root of 1 minus x minus 8x cubed all over 11. We're then going to generate x1 by transferring our y coordinate across to our x coordinate. We need to go across to our y equals x line, and we're going to keep using that iterative process of going from our y equals x line to our y equals the square root of 1 minus x minus 8x cubed all over 11 square rooted. And you can see very clearly what's happening here, that actually we're not going in the direction that we want. We want to head towards the root, and this is heading away from the root. And that would just keep going and keep going. The root is up here, it's where the two graphs intersect, and so the method isn't working with this particular root. So why won't this iterative formula work for all the roots? Well, I've gone back to our original graph of the two equations, y equals x, so sorry, the two graphs, y equals x and y equals the root of 1 minus x minus 8x cubed over 11 all square rooted. And we're looking at the points of intersection. Now, these 2 points of intersection, you can see that the gradient of the blue curve is, in this point here, it's a negative gradient, but it is between -1 and 1. So it's negative, but it's not quite as steep as -1. And the gradient at this point, because the blue curve is cutting across the y equals x line, which of course has a gradient of 1, that the gradient here as well is between -1 and 1. But if we consider this root here, this point of intersection here, you can see that the blue curve is cutting across the y equals x line, and so the gradient here is greater than 1. And so the method of using the fixed point iteration with the particular rearrangement doesn't work at that point. So I've just made these notes. I'd like you to copy them into your book, and it just summarises some of the key points that we've been talking about, specifically the gradient of the curve. Now, I've introduced g of x, and in the example that we've done, then g of x is this y equals curve that we've been using.